Hey there, this is Akshit Madan and welcome back to a new video. And in this video, we are going to create a Dapp. So Dapp is basically a decentralized application. Now, what do you mean by decentralization or decentralized? So an application that is not under any authority or it is not centralized, it is called a Dapp, right? And it can operate autonomously, typically through the use of smart contracts. So what are smart contracts? So smart contracts are the contracts or the codes that are written on the blockchain. That means once they are deployed, they cannot be changed forever, right? They can never be changed, right? So what are we going to build today? So we are going to build a voting Dapp or an election Dapp. So what will happen in our application is there will be an owner of the application, owner of the Dapp, or the owner of the election. Let's say Election Commission of India. Let's say Election Commission of India is holding an election for Prime Minister of India. So they can start this election. So they can deploy this smart contract and they need to authorize the voters. Let's say voters should only be Indian, voters should not be less than age 18, kind of this. And they are only going to authorize the voters and they are only going to add the candidates. Let's say Election Commission of India is going to say that PM Narendra Modi is standing in this election, Manmohan Singh is standing in this election, or someone else is standing in the election, right? So they are only going to add the candidates, they are only going to authorize the voters. Then after the contract is deployed, voters can vote for a candidate. So this complete project, we are going to build today in this session. And I believe that after building this, you can also put this project in your resume also, or you can also create something else by your own, right? So I hope that you will like it. So let's begin with understanding the concepts of blockchain, Metamask, smart contract, Solidity, and all that. So let's do it. So our first task is to create a Metamask wallet. So if you don't have, so as you can see in my case, I already have this Metamask wallet extension and you can see that I already have some test Ethereums. So if you don't have much knowledge about Metamask or if this is your first tutorial, then just know that there are two networks. First one is the mainnet network and second one is the test networks. And these are all the various test networks that we are provided in the Metamask. So if you will go to Ethereum mainnet, there you can see I don't have any Ethereum because mainnet consists the real Ethereums. So if you will work with mainnet, then there you will be charged with real Ethereums. So you should not work with Ethereums, the mainnet Ethereum, if you are creating a project, right? Or you are doing it for test purposes. So I'll shift to Kovan test network. So you can also shift to various test networks, but this Kovan test network, I'll show you how you can easily get free test networks, free test Ethereums in the case of Kovan. Actually, basically people use Ring-B, but I have seen that Ring-B is not available most of the time. That's why I work with Kovan. So what you have to do is, you can see I am having 0.11 Ethereums in my Kovan account 1. So this is account 1, and you can see there are various accounts. In account 2 also I am having 0.04 Ethereums. So to work or to create a smart contract or to deploy a smart contract, you need some Ethereums. And in this case, we need test Ethereums, right? So how you can get these test Ethereums? So you just have to do one thing, just search for Kovan test faucets on the internet, and now you need to go to Chainlink link. Yeah, this one, faucets Chainlink. Now go over here, and now over here you need to put your address. So what I'll do is, you can see over here. Now how you can first of all install the Metamask wallet. So it is very simple. So I'm on metamask.io website. Just click on download now, and over here just click on Chrome. So as you will click on install Metamask for Chrome, then your Chrome extension will be installed. Just create an account, create a simple password, then you will also get a private key or some like keys. Then you have to store that key very safely. So just do that and it will be done. So you will get this Chrome extension icon over here, right on the top bar. So this is very simple. I know that you can do it by your own. So how you can get the faucets or the test Ethereums? So now just copy the address. So let's say you can see in account number 2, or let's shift to account number 1. So in account number 1, I already have 0.1. So just copy this address. Just click on this and your address will be copied. Now go over here and paste the address over here. And 10 test links. Okay, 0.1, you will get 0.1 Ethereum. That is totally enough for this project. And click on I am not a robot. And click on send request. So it will be initializing and you will get 0.1 Ethereums. So let's go over here and let's see. So first of all, I'm having 0.1. It should be 0.2 now. So let's wait for some time. Yeah, so it is doing it. Transaction hash, 10 links, and it is totally fine. Yes. Okay, it is currently running. So as you can see, it is completing the process. So let's wait. So now over here I can see success. So let's wait for some more time. So it is still waiting for the confirmation. So now let's just check our MetaMask. It is still confirming. So let's see. Okay, so I've got 0.21 Ethereums. Now what I'll do is, so all these Ethereums are fake. They are not real, right? So now what I'll do is, this is account number 1. And now my focus is to, now my task is to send 0.1 Ethereums from this account 1 to this account 2. So here you can see it is having 0.04. So now my task is to make it 0.14. So I'll go to I go to account 1 and I'll click, first of all, I need to go to account 2 and copy the address. And I'll click to account 1 and click on send and search for the address. So paste it over here and you need to put the amount. So it is 0.1 Ethereum and click on next. So now let's wait and click on confirm and it will be sent. So it is currently pending and it will take some time and the 0.1 Ethereums will be sent. So it is like prompting for speed up. So if you will speed up, then more gas fees will be charged. So what is gas fees? So all these functions which I'm doing, like all these tasks which I'm doing, like sending Ethereums, getting Ethereums, all these are not free, right? So you have to pay some fees to the miners, so that, because nobody is going to do something for free. So we have to pay a very little amount in the terms of gas fees to the miners, so that they confirm or they verify our transaction and they put that transaction in the block, and then that's how the blockchain is created, right? So this is the task. So 0.1 Ethereums are gone, and now let's come to account 2 and you can see 0.1498 Ethereums. Perfect. So this is how you work with like accounts, right? So this is very simple. And again, don't work on mainnet. There real Ethereums will be charged, right? So just shift to Quant test network, go on Chainlink, get 0.1 Ethereum, then you can like send Ethereums, receive Ethereums to your different accounts. Now, why do we need 2 accounts? So what we are doing currently is, and what we are going to build is, we are going to create a voting decentralized application, right? So today, what we will do is we will create a smart contract where an admin will be there, and that admin and whosoever is there on the smart contract will be assigned an account, right? So let's say this account 1 will be assigned to my admin. So the person who is creating the smart contract or the person who is deploying the smart contract, right? So an admin is there, and you can consider, okay, let's consider the Election Commission of India. And over here, Election Commission of India is the account 1 or the admin who is creating the election or who is organizing the elections, right? So the admin is going to put the election name, like this election is for Prime Minister of India, this election is for President of India, just an example, right? This. So he or she is going to put the name of the election. Then he or she is, or the admin is only going to authorize the voters, like who can vote in this smart contract or who can vote in this election. So let's say only the people of India. The person who is not from India cannot vote, right? Or the person who is below the age of 18 cannot vote, like this. And this account 1 or this admin is only going to add the candidates, right? The candidate can be like a person who is sitting in the election or who is standing in the election, and different candidates can be there. So this account 1 is only going to add the candidates in a list, right? So all these candidates are there, and voters can vote for a particular candidate and their votes will be incremented. Perfect. So this is our task. So that's why we need 2 accounts, because account number 1 will be the admin and account number 2 is going to be a simple voter. And this account 2 is also requiring the Ethereums, because when the person will vote, then he or she will be charged some gas fees because he's calling a function or he's creating a function, kind of that. So I hope you understood. Now it is the time to code the smart contract, and it is very simple. You just have to believe, and let's start. So what you have to do is just go on the internet, click on or search for Remix IDE, and let me not just go over here. Let me just search for Remix so that I can show you what we are doing. Okay, so yeah, this is Ethereum IDE. Just go over here, and over here we are going to like create a contract. So over here what I'm going to do is just click on this button. So this button is for create a new file, and over here we are going to write our contract. Over here we are going to compile it. Over here, from here we are going to deploy it, right? So everything we'll be covering in this video. So let's first of all create a smart contract. And if you are not having very deep knowledge of Solidity or not even intermediate knowledge of Solidity, that is totally fine. This video is for beginners, and let's do it. So I'm creating a contract. Let's call it election.sol. So sol means Solidity, and first of all we need to define a license, right? So like license, simple license. So let's put comments, and inside this comments we have to write the license. If you will not do it, it is going to give you the errors. So over here you can see that I have put a license. So let me just increase the font size also. So here you can see I have put the license, and I have also put the Pragma Solidity version. So this is the version of Solidity that we are going to use for this smart contract. So this is it. Now the next thing is we need to define a class. So in Solidity or in smart contracts, instead of defining a class, we define a contract. So let's define a contract, and this contract we are going to call it election, and simple curly brackets as we do in class. And now we need to define a candidate. So what is a candidate? So I hope you know data structures and algorithm, and in that data type there is a data type called struct, right? So that same thing we are going to define struct, and this struct is going to be called as candidate. So this struct is going to hold the information of candidate that we are defining. So the first information that we are going to define is the name of the candidate. So let's define string name, right? And the next thing that we are going to define is the number of votes this candidate has got. So that will be in the form of uint. So uint is the just big int, and uint you can just consider it int for now if you are getting confused, right? So let's consider uint, and it will be num votes. Perfect. This is it. So this is my one candidate. Let's put the semicolon. So this is my one candidate. So all the candidates will have a name and the number of votes they have got. Simple. Now what we'll do, we will create a struct for a voter. So what information we are going to store in for the voter, that will be stored in this structure. So struct will be a voter, and over here we are going to get the name of the author. So it will be in the form of string. So string name. The next thing will be a boolean, whether this voter is authorized to vote or he or she is not authorized to vote. So it will be authorized. And the next thing that we're going to define is whom, like who this person is voting, or whom this voter is voting. So it will be whom. I'm defining this whom as uint because we are going to create a list of candidates, and in that list which candidate I am voting, so I'm going to vote to the index of that candidate. So let's say there is a list of candidates, Akshit, Asif, Karan. So there are 3 candidates who are fighting for being the president of India, let's say, right? So let's say there is a voter X, and he or she is voting for index 0. And what is that index 0? Akshit. So it is clearly depicted that he or she is voting for Akshit. So index 0. So that's why uint, that means the index of the candidate in that particular candidates list. Simple. So let's go next. And the next is boolean voted. So we are storing also boolean value whether the person has already voted or not. Because if the person has already voted, then he or she is not having an authority to vote again. Simple. So boolean voted or not. That's it. So this was the structure of my voter. Now the next thing that I'm going to define is the address of the owner of this smart contract. So let's define address. So this is again a data type in Solidity Smart Contracts. So it will be address public. So everyone can see that who is the owner of this smart contract. It is not hidden from anyone. So if this smart contract is being deployed by Election Commission, then they will be the owner of this smart contract. So owner. The next thing that I'm going to define is election name. So it will be whether this election is for class monitor, whether this election is for the president, prime minister, kind of that, right? So it will be string public again. That means it is visible to everyone. String public election name. Because people should know for what election or which election they are voting for. Simple. The next thing that I'm going to do is a simple mapping. So over here what we need to do is mapping. Address will be mapped to a voter. So what I'm going to define is address will be mapped to a voter. So as we already saw that account number 2, we are going to denote to a voter. So this account 2, it is an address, right? It is a long Ethereum address. So this address should be mapped to a voter. And what is voter having? It is having all these informations. So it is going to get cleared once we will code it completely. And it is also public. We can see the voters information, and it will be called voters. So this voters is a mapping, or you can consider it as a dictionary. Simple. If you are familiar with Dart and Python. So voters is a mapping which is going to contain addresses, and each address is going to have this information, this structure. Simple. Now we are going to create a list of candidates. So that candidates list is going to have only candidates. So the type of that array is going to be candidate. So candidate and list. So we define list like this in the Solidity Smart Contract. So let's say your list was containing only integers or strings. So then you can define string. But over here we are going to define a list of candidates. So candidate list, and it is going to contain, it will be public, and it is going to contain a candidate. So this candidate is a variable name. So candidates, right? So this candidates is the name of that list. Perfect. So now I'm going to define uint, the total number of votes I have got. So public, and it will be total votes. Perfect. So this is all done. So now our main thing starts, and from here we have to start writing the functions. So let's define the first function as start the election. Function start election, and over here it is going to take the name of my what we can say, the name of the election. So it will be election name. So it is function start election string election name, and yeah, that is it. And let's make it public. And so as soon as the election will start, who will be the owner? So this is the owner. It is currently empty. The owner will be the person who has triggered this election. So message.sender. So the person who has deployed this smart contract or who has started this contract, he will become the owner of this election. Owner is equal to message.sender, and the election name, which is over here, election name, this one, let's make it a little different. Yes. So election name, I'm referring to this one. So it will be election name is equal to the parameter that we have got. That is done. Our election has started. Let's go to the next function, and this function is going to be add the candidate. So function add candidate, and this is going to take the name of that candidate. So it will be string memory, and it will be small s string memory, and it will be candidate name. Now there is one problem over here. So what is that? Anyone cannot add a candidate, right? A voter cannot add a candidate. The election commission or the owner of this smart contract can only add a candidate. So for that purpose, we need to write some modifiers. So let's write a modifier, and you will understand what is the meaning of this modifier. So this will be a modifier, and it will be owner only, right? It will be owner only, and it will mean require, and it will mean that only the message.sender, if the message.sender, that means the person who is currently on the smart contract, who is dealing with this smart contract, equal to owner. So if the person is the owner, so owner is the person who has deployed this smart contract as we have defined while starting the election, right? So if this person is the owner only, then go ahead, otherwise don't go ahead, right? And how can we use it? Just copy this and write it over here. Now what will happen is only the person who is the owner of this smart contract will be able to call this function, add a candidate, right? And let's make it public. And how can we add a candidate? So what we will do is simple candidates, that is a list of candidates dot push. And in this, while pushing it, we are going to push a candidate and with the name. So as the candidate is a structure, and we are going to put the name, so candidate name, and we are going to put number of votes as 0. So as you can see over here, the candidate takes two parameters, name and number of votes. Initial votes will be 0, name will be the name that is provided through the parameter. That's it. Using this function, our candidate is added to the list of candidates. Simple. Now I'm writing a function to authorize a voter, right? So I'm going to write a function to authorize a voter, right? And this function will also be called only and only by the owner right? So it will be address, the person who is voting currently, or who is the person who is dealing with the smart contract. So we will take the address of that. So it will be voter address. And in this case, for our test purpose, we are taking it account number 2, right? So voter address, and it will again become, this function will be voter owner only, and this function will also be public. And we are going to check if voters, so which the voters is again mapping, right? So voters we have defined over here. So this is a mapping, right? So if voters at the voter address, what I'm doing is voters at the voter address dot authorized is equal to true. So now what we did is we did a very simple thing, voters at voter address. So voters is a mapping. So over here you can see voters is a mapping and address is the key, value is a voter. So key value pairs, right? That happens in a simple dictionary also, key value pairs. So key is the address, value is the voter. And voter is what? Voter is a structure which is having all this information, right? So voters at a particular address, the person who is trying to vote or the person whom the owner is trying to make it authorized. So voters at the voter address, particular voter address dot authorized, make it true. So the same thing, voters at voter address dot authorized is true. That means this voter address is now eligible to vote. That's it. So authorized voter is also done. Now I'm writing a function to get all the candidates, to get the candidates count. So I'll write a function get number of candidates and let's make it public so anyone can see how many candidates are there, because people have a right to know how many candidates are standing in the election. So it will be public view returns. So if we just have to view something, then we just use public view returns, and it will be returned in the format of uint, and we are going to return candidates dot length. Perfect. So this is the function which is going to return me the number of candidates. Simple. Now we are only left with one thing, that is the function to vote, right? So let's write that function vote, and this is going to take this function is going to take only and only one parameter, that is the index of the candidate. So it will be candidate index, and it will also be public. But here we need to check a few things. So first thing is voter should not have already voted, right? So it will be require, and you can again make a modifier for it. That's totally up to you. So voters at message.sender. So now I'm not using voter address, I'm using message.sender, and message.sender just means one thing, it returns you the address of the person who is currently working on the smart contract, or the person who is currently dealing with the smart contract, right? Or the current user address. So message.sender dot voted should not be true. So what happens if it is false, then go ahead. So it will be semicolon, and one more condition, that person should be authorized, right? So require it will be voters at message.sender dot authorized. So if the person is authorized, then go ahead. So again we'll write voters at message.sender, and it will be dot whom the person is voting. So as you can see in the voter structure, I am having whom. So this is the index of the candidate that the current voter is voting for. So this will become my candidate index. Simple. And the last thing is we will make this voters voted is equal to true. So voters at message.sender dot voted, now it will become true. That means the person has now voted. So the person should not be able to vote again. So now we will also increase the number of votes for that candidate. So candidates at candidate index dot number of votes plus plus. So here you can see candidate is also having number of votes, right? So we will increase it by 1, and we will also increase the total number of votes plus plus. So here you can see total number of votes is defined over here, and it is currently 0 by default, and it will be incremented by 1. So with this, our smart contract is ready. So now let's try to save it, and we are having some error. So let's see. Okay. So we are having a simple error. Okay. Instead of curly brackets, I wrote the round bracket. So it will be like this, and there is no semicolon after that. And the same thing we will do over here by mistake. Yeah. So let's just save it, and we are having error over here. So let's see. Yeah. So we need to put a semicolon. Okay, not over here, we need to put it over here. So let's save it, and the same way we have what is there but got return. It is returns. Yes. So as you can see, instead of return, we need to write returns, right? This is done, and you can see the green mark over here, which means the smart contract is compiled successfully. And this is all done. You can just click it also. Now we need to deploy it. So first of all, let's try to deploy it on test network. So this is JavaScript virtual machine London. So let's try to deploy it, and you can see over here you get so many addresses, and they are all having 100 ethers. So now let's see what happens. So let's try to deploy it. You can see nothing is deployed. So let's click on deploy, and you can see my smart contract is deployed, and you can see one contract deployed over here. So let's click on it, and you can see all the functions. I'm going to access it from here. So if I just click on owner, so you can see the person who has deployed this smart contract, right? So over here you can see some gas fees is also paid on deploying it, and it is very, very less. Perfect. And this is the address of that person, who has deployed the smart contract. Now if I'll check election name, nothing is there because no election has been started. So let's write over here the election name. So you can see it takes the election name as the parameter. So let's write a simple name as class monitor. So this election is for the class monitor. So class monitor, and I'm going to click on start the election. So as soon as I'm going to do it, and now if I just click on election name, you can see class monitor, right? And if I just click on candidates, there is no candidate right now. And if I just uint 256, that means the index of that candidate. So let's write 0, and it is not there because no candidate has been added. So over here we need to write a name of that candidate. So let's write Akshit, who is standing in this election. So let's click on add candidate. And now if I just go over here and write 0, that means index 0, and click over here, you can see Akshit. So this is the name of the candidate that has been added, or who has been added, right? So now what I need to do is get number of candidates 1. Let's add one more candidate, and let's name it Asif, and let's click over here. Now if I'll click on get number of candidates, it will be 2, and let's write 1 over here, that means index 1, and you can see Asif over here. Perfect. So this is working perfectly. Now let's try to authorize a voter. So let's go on address number 2. So this address is again having 100 ethers. Let's copy the address, and let's again go to account number 1, who is the owner, because owner is only going to authorize a voter, right? So let's go over here, paste the address, click on authorize voter. The voter will be authorized to vote, right? So now if I'm just going to, now I'll be going to account number 2, that means voter account, and now I'm going to vote for a candidate. So vote the index of that candidate. Let's say I want to vote for Akshit, that is index 0. So put index 0, click on vote, and Akshit will have number of votes +1. And let's go to account number 1. Over here you can see again the gas fees is paid because the voter is running a function, so gas fees will be paid. Now let's go to owner, and let's try to see candidate 0, that means Akshit's account. So over here we can see number of votes is 1. Previously it was 0. So like this we have created a smart contract, and if you will see total votes, it is 1 because only one voter has voted till now. So this is the smart contract that we have built, and this is working perfectly. And now how you can run your smart contract through your Metamask wallet. So now you want that this should be your owner, and account number 2 should be your voter, right? So you need to do one thing, just click over here and click on Web3 provider, and it is going to not Web3 provider, it is injected Web3. So let's go over here and click on injected Web3, and it will automatically open your Metamask, and it is going to connect it automatically. So if you will be doing this for the first time, then Metamask will open, and you will be prompted to sign your interaction. But I have already done it, and so you can see Kuan is connected because I am on the Kuan network currently. So Kuan is connected, and you can see only one account right now, right? 0x759, right, which is having 0.11 Ethereums. So now if I shift to account number 2 from here, so now you can see 0x755, which is having 0.14 Ethereums. So whichever account I'm going to change from here, it will be changed over here also. But this is not our purpose. Our purpose is to run everything through a simple mobile application. We don't want to interact through here, right? And you can see deployed contract is gone, right? Because we haven't deployed any contract using these accounts. So now our main focus is to create a decentralized application which will run all these functions through a simple UI which a normal user can also understand. So let's shift to VS Code. So now you can see that I am on my VS Code and nothing is running. I've cleared main.dart because everything we are going to code from the scratch. And you can see I've created an assets folder. It is currently empty. And we are going to put one file that is the sole entity that is going to connect your smart contract with your front end Flutter application, right? So first of all, let's create the basic things that you're already knowing. So let's import material.dart. And let's create a void main function which is going to initialize the main app. So void main run app, and it will be my app. And now we need to create a stateless widget which is called my app, and it is going to return you a material app which is having first of all, we will remove the debug banner, that is a red banner that is there on the top right corner. So it will be debug show banner, it is false. Next, I'm going to define the theme. So I'm going to use dark theme. So it will be theme data. Brightness I'm going to define as brightness dot dark. And I'm going to define the primary color as colors dot deep purple. And then I'm going to also define elevated button theme so that I don't have to design the buttons every time, because we are going to use many buttons. So elevated button theme will be elevated button theme data, and it is going to have a parameter called style, and this is button style. Button style will have a color or the background color, and it will be material state property dot all colors dot deep purple only, same color. Next, after the elevated button, we will be defining the app bar theme, and only one thing that I'm going to define is app bar theme data, app bar theme, okay, and it is going to have elevation, and I'm going to make the elevation as 0. Perfect. So let's do only this much for now, and let's create the folder structure. So first folder that I'm going to have is the pages. Next I'm going to have is the widgets. Next I'm going to have the utils, and I think this is it. And yes, services, which is going to have all the functions to interact with the smart contract. Utils will have a file called constants. So this constants file is going to have all my addresses, the Ethereum addresses, like the admin address, the voter address, because currently we are creating a single user application, right? If you want to scale it up, then you can define it. You can prompt a user to enter its private key, enter his or her private key, and then you can work with any user. But currently we are working with only two accounts, account 1 and account 2. So we will like statically define their private keys, right? This is it. And now we need one thing in the assets. We need to create a file called abi.json, and abi.json. And where will you get the content for this? So just go on your smart contract, and over here, yes, so just save this, and in the compile button, you will get this ABI. Just copy it and just paste it over here. So this is like a JSON which is having all the information about your functions, so you can interact with your smart contract and your front end. Now we need to do one more important thing, that is Infura. So you can use Ganache, you can use Truffle, and if you're working with a Solidity Smart Contract, you can also work with Infura. So just create an account over here and click on Visit Dashboard. Create a new project and select Ethereum, ETH2, give a name and click on Create. I've already created an app called Voting Dapp, so I'll click on Settings, and from here I'll get all the things or endpoints that I really need, right? So in the endpoints, as you know that we have not deployed our contract on mainnet, we have deployed it on Koan test network. So click on Koan. So if you're using Rinkeby, then click on Rinkeby, and these are the two things that we will require. So these are the URLs, not the second one. We will just require one URL, that is the first one, right? So just click on this, and in the constants.dart, just create a string and call it Infura URL and paste that URL over here. So what this is going to do is, you can see that this is also connected to your Kovan, and you are on your Kovan network, and your smart contract, this also we are going to deploy it on your Kovan test network, right? So all three are linked. So Infura is a thing that is going to help you to interact your smart contract with your front end. That's it. Simple. So the work of Infura is completed over here. Just make it active and it is done. Perfect. So now you are ready with your Infura URL, and now we will require to add the private keys of your owner and your voter. So why do we need private keys? Because whenever you use a function, or when you call a function, you are charged with gas fees. This you have already seen, that if you will call a function, you will be charged some gas fees. So to pay the gas fees, you require that private key. Otherwise, anyone can use your public key and pay through your account. That's why we need a private key to sign the contract. So what we'll do is we will go on our Metamask, and this is my account 2. So let's first shift to account 1 and click on these 3 dots and click on account details. Click on export private key. Type your password. So password is typed, and this is my private key. So this is not my real private key. This is a test Metamask wallet. So you can also do anything what you want, but use your own private key. So I'll write string owner. Account 1 is the owner of the smart contract, right? So owner private key is equal to this and this. That's it. Now we will write one more thing, that is called string voter private key. Voter private key is equal to, now we will go to account 2 and export that private key. So let's shift to account 2, which is my voter, and I'm going to click over here, then account details, click over here, then write your password. Click on confirm. This is my password. This is my private key. Paste it over here and done. So we are ready with owner private key, voter private key, Infura URL. So I think this is it for now. Now what we need to do is we also require the contract address, so that you are going to get from here. So when you have deployed it, so when you will click on deploy, there is one contract that is generated, and we need to copy the contract address. But first of all, let's code some UI, right? So let's keep it as it is, and let's in the pages, let's create a file called home.dart. Perfect. And let's import material.dart, and let's try to create a stateful widget. Let's call it home. So now in this home, first of all, we need to define 3 variables. So first one is your HTTP client, then your Ethereum client. So these are the clients that are going to interact with your smart contract. So for that, in the pubspec.yaml, as you can see, I've already imported my assets, and I've also added 2 packages, 2 dependencies, web3 dart and HTTP, right? So that's why I will be able to add 2 things, that is HTTP client. So let's call it client, and let's call it HTTP client. So let's import first of all this client, then HTTP client, and second one will be my web3 client. So web3 client, and let's call it Ethereum client. So ETH client. Perfect. And next one will be my text editing controller that we can add later. So now let's initialize these 2 clients. So init state, and let's initialize them. So the thing that you need to run is your HTTP client will be a new client. So client, this is it, this is done. And my ETH client will be web3 client, and over here you need to define your URL. Now this URL will be your Infura URL, through which you are going to interact with your smart contract. So Infura URL, and HTTP client is the HTTP client that we have defined above. That is it. So HTTP client, we will need to put a null check. This is it. So now your clients are initialized. So these are the 2 clients that we are going to use in our whole application. Now we need to define, now we need to code the UI, and I'm going to write a scaffold, and let's define the app bar and app bar. So this is the first page from where we are going to start the election. So in this page, we will have only one text field to write the election name, right? As we were writing over here, I write the election name, right? So that same thing. So let's write the title text start election. Perfect. And it will not be having anything else. Let's define the body. It will have container. Let's define child. Let's define column. Let's define children. Perfect. And let's make it main axis alignment dot center. Perfect. And I think everything is done. So let's first run it. So in the main.dart, let's call in the material app, let's call home as my home. Save it. Now let's wait for it to run. So over here you can see the app bar and nothing is there. So let's go to home and let's define one text field. So I'll define one text field, and over here I need to define now a text editing controller so that the person has written some name. It should not be empty. So I'll define a controller and it will be initialized with text editing controller. Perfect. So in the text field, I'm going to define my controller as my controller, and it will be having some decoration, the input decoration. Input decoration, where is it? Decoration. The field will be true. And it will be having some hint text. Enter election name. Save it. You can see the text field. Now let's add a button, elevated button to click and start the election. Elevated button, and it will be like this. Child, let's make it text start election. This is it. Let's wrap this elevated button with a container. Let's make the width as double dot infinity and height as 45. Perfect. Now let's give some sized box between them. Height 10. And let's give padding to the whole page. So container will be having a padding, edge insets dot all 14. Perfect. So this looks good. So as soon as I'm going to click on start election, my election function, that is start election function, that means this function should be started in the backend, right? How can we do that? So for that, we need to code some functions. So in the services, I'm going to create a file called functions.dart. And over here, we are going to write all our backend functions. So like how can we use our clients to interact with the smart contract, right? So our first function is to load the contract. So this is the contract. It is at the backend. So we need to load it from the front end. So, and it is going to return you a deployed contract in future. So it will be future, type will be deployed contract, and let's call it load contract, and async, of course. And okay, it is not returning anything else till now. So first of all, we need to define our string ABI. So ABI.json is over here. Now we need to load this ABI.json. We have loaded the ABI.json. That means we have loaded the smart contract, right? So it will be await. So for this, we use root bundle dot load string, and over here we need to define the path. So assets slash ABI.json, ABI.json. Perfect. And after this, we need to define our string contract address. So this time we will require the contract address. So now let's do one thing. It is on Koan. I'm using, let's shift to count number 1, which will be my owner. Perfect. Now let's click on deploy. So it will take some time, and this time I also need to confirm the transaction, because it is considering it to be a real account, but it is test account, but still we are interacting with MetaMask. So now the contract is deployed. Over here you can see my deployed contract. We can work from here also, but we need to do it from Flutter. So let's copy this address. So this is the contract address. So let's copy it from here. In the constants.dart, let's define string contract address is equal to, paste it, save it. Functions string contract address will be my contract address. Perfect. Let's import. Okay, so let's define. So let's change the name. Okay, so because these two are having same name, so let's go to constant.dart. Let's make it contract address 1. Let's save it and let's make it contract address 1. Perfect. Now what we need to do is we need to finalize the contract. So final contract is equal to my deployed contract. Everything is coming from Web3 dependency, right? So ABI will be my ABI. What is the error? Okay, null check. Not null check. The type string. Okay, so it is deployed contract. Instead of just writing ABI, we need to write contract ABI dot from JSON. Perfect. This is JSON, right? This is not the ABI. So it will be ABI. Name will be election. So election, it is coming from this one, contract, right? So name of the contract is election, and address, address will be contract address. Perfect. Now it is again having some problem. So it is Ethereum address dot from hex. So it will be Ethereum address dot from hex, and hex will be my contract address. Perfect. And now we can return the contract. Perfect. So this is it. So the next function that I'm going to write is call function. So like we can give the function name. So let me just do it. So function, it will be called future, and it is going to return me a string, and it is called call function. So it takes the string function name first of all. So string function name. So what is function name? Function name is this function name. This one, this one, this one. So this we can call through this function. So it is going to take the string function name, and it is going to take the list of the arguments. So list, and it is going to be dynamic, and it will be arguments. So arguments are nothing but this is an argument, then this is an argument, this is an argument, right? So if there is no argument, like in this case, then you can keep the empty list, right? And the next thing that is going to take is a Web3 client, right? Web3 client, and let's call it ETH client. And next thing, it is going to take the private key, like who is calling this function. So if the owner is calling, then owner private key. If the voter is calling, then voter private key. So it is going to call it will be string private key. Okay, and this function will be async. And now ETH private key, Ethereum private key, credentials is equal to Ethereum private key, ETH private key, and from hex, because it is an address and we need to convert the address into Ethereum private key. So it will be from hex, and the hex is going to be private key that we are taking from the parameter. Next is a deployed contract. Deployed contract is nothing but the contract that we get from loading the contract. So deployed contract, and it is equal to await load contract. Perfect. This is also done. Next thing is a function. So final Ethereum function, ETH function, is equal to contract dot function. So from the smart contract, I am calling the function with the function name, func name. It will be func name. Perfect. So I'm calling the function name, right? And now what result I'm going to get from that function, like calling the function, it will be final result is equal to await Ethereum client dot send transactions, and it is going to ask for the credentials. So credentials will be credentials that we have defined above. Transaction will be my transaction dot call contract, and it is going to take my contract is my contract that we get from loading the contract, like this one. The next parameter is my function. So function is my Ethereum function that we have defined over here. And the next one is the parameters. Parameters is nothing but args that we have taken as the parameter of this function. This one I'm talking about, right? So, and finally I'm going to return my result. Return result. Perfect. So this was the function for calling the functions. So now first function that I'm going to call is my start function. Oh, sorry, start the election. This one. This one, right? So let's call it. So how can we call it? So it will also be future, and it is going to return me a string, and it will be, let's name it start election, and it is going to take the name of the election. So this name is nothing but the name that the user is going to input in this text form field here, right? Name of the election and the web3 client, and web3 client, let's call it ETH client. Perfect. And it will be async. Now var response is equal to await call function, the function that we have defined over here. This one we are going to call. So call function name. So what is the function name? Function name I can directly copy from here. So let's copy this, paste this. Arguments is nothing but it is just a list with name that the user has entered over here. Private key will be owner private key, right? Because owner is going to call this function, nobody else. Perfect. And after this thing is done, so I'm going to print election started successfully. Perfect. So this is it, and return the response that you are getting. Perfect. That's it. So this was a function to start your election. Now I'm going to write a function to add the candidate, right? So this function I'm talking about. So let's copy this and let's paste it. And the changes that we are going to do is it will be add candidate, and it is going to take a name of the candidate. It is going to take the Ethereum client, and nothing is going to change, and everything will remain same. And we need to copy this function name and paste it over here. And this will also be called by the owner. So owner private key. So this was it. And let's call it candidate added successfully. Candidate added successfully. Perfect. And the next function that I'm going to write is my authorize voter. So let's copy this again. Let's paste it. Let's name it authorize a voter, and this is going to take the address. So it will be string address, not this one, string address, or we can call it voter address, or you can keep it address. So this is it and nothing else. And the function which I'm going to run is my this one. So let's copy this, let's paste it over here. So, and the parameters is nothing but a single parameter, but we cannot give the address in the form of string that we have accepted over here. We need to convert it into Ethereum address. So what we will do is we will write Ethereum address dot from hex, and my hex is voter address, or sorry, the address. Perfect. And this was it, and everything will remain same, and we can write voter authorized. Next function I'm going to write to get the number of candidates who are there, right? So it will be future. It will be a little different, and it is going to return me the list. And let's write get candidates number, and it is going to take just web3 client. Let's call it ETH client, and it will be async, and it will be returning list of dynamic, and it will be called result is equal to await like let's call this function as get number, or let's call it ask. I'm going to code this function ask, don't worry. And we need to give first of all the function name. So this one is the function name. So let's paste it over here. Then list of arguments. So it is empty because it is not taking any argument. And finally the ETH client, that's it. And we can return the result. Now let's create this function ask. So let's code it. So this asks is a future function. So future, and it returns list of type dynamic. And this function is called ask. It takes the function name and it is in the format of string function name. Then it takes the list of arguments. So list dynamic args, and it takes the web3 client. Let's call it ETH client async. And it is going to first of all we need to define the contract. So it will be final contract is equal to await load contract. Perfect. And next thing is the Ethereum function. So final ETH function is equal to contract.function. The function name that we have got in the parameter function name. This is it. And finally final result is equal to ETH client dot call. The contract is my contract, function is my ETH function, parameters are my args, and you need to return the result, and it will be in the format of list. This may sound a little tricky, but as you will go through all these functions once more, it will become very simple. So let's see. So we have coded almost all the functions. Only one is left, that is vote, like the function to vote a candidate. So let's write that also, and then we will see what all we have coded. Let me just close this out. Yes. And let me just decrease the size of this phone for now. Yes. So it will be future, and it will be in the format of string. The function is called vote, and it takes the index of the candidate from the candidates list. So it will be candidate index, right? And it takes web3 client. It's called ETH client, and this function will be async, and it will return a response. So where response is equal to await call function, and we are going to call the function of vote. So let's copy this vote and put it in the strings arguments. So it takes only one argument, that is int candidate index. So let's call it we can, and yes, one more thing. So this thing we cannot like give the index in the format of int, because uint and int are different. So uint is a big int. So let's write a list, and inside it we need to write big int dot from, and over here we can define candidate index. Yes, because it will convert int to big int. And the private key, yes, over here the private key will not be my owner private key, it will be voter private key. So voter private key. Perfect. This is it. And we can write, or we can print voter vote counted successfully. Perfect. And return the response. So we have coded all the functions. So this function is for voting. This function is for getting the number of candidates. This function is to just call this function. And this function is to authorize a voter. This function is to add a candidate. This function is to start the election. and this again is a helper function, and this function is to load the contract. Backend is complete, right? Congratulations, backend is complete. Now we need to just code the front end. So as soon as I'll click on start election, I'm going to call my start election function. So let's go on home.dart, and I'm going to create one more file called election info, which is going to show me all the information, who are all the candidates, how many votes, how many candidates, all that. So election info.dart. First of all, let's go on home.dart. As soon as I'm going to press it, I'm going to check if my controller dot text dot length is greater than 0. Then I'm going to call the function start election. Name of the election will be controller dot text, and ETH client will be ETH client that we have defined above with a null check. So this is the Ethereum client that I'm talking about, that we initialized previously. So this is it. As soon as you will click on ETH client, your function will Ethereum start election function will be called, and this function will be triggered, this one. So I think we should try it, but first of all we need to, yeah, everything is done. I think we can call it. So you can see election name, it is currently nothing, but as soon as I'm going to write something and click on start election, it should be visible there. So let's try it. Why are we waiting till now? So let's refresh everything. And yes, so as soon as I'm going to click it, I want to move to election info page. So what I'll do is, so let's import material.dart. Then let's define a stateful widget. Let's call it election info. And we are going to take two parameters from the previous screen, that is final web3 client that was initialized in the home.dart. So let's call it ETH client. And next thing will be final string, the election name, that the election which we have started, final string election name. Let's create a constructor. Let's make them required, this one also, and okay, yeah. And in the widget, I'm going to return a scaffold. Let's return an app bar, the app bar with a title, with a text will be nothing but widget dot election name. Let's run it, and over here, as soon as in the home.dart, as soon as my election will be started, I'm going to make it async first, and let's make it await. And after this, I'm going to write navigator dot push. Route will be material page route context, and it will be election info. Ethereum client is my Ethereum client, and election name is controller.text. Perfect. This is it. So let's see if we get any errors. Let's refresh it, and let me just write an election name as class monitor. Let's click on start election, and let's wait. Okay, we are getting an error, invalid chain ID. Okay, the solution is here. So actually in this send transaction function, we have two more parameters. So let me just paste it. First one is your chain ID, second one is your fetch chain ID from network ID is true, and chain ID is your null, right? So these two parameters we forgot, so just add these two parameters in your call function, main function, right? So that's why this chain ID invalid chain ID error was there. So let's refresh it, and let's write class monitor as the election name. Let's click on start election. This time hope we don't get any error. And yes, election started successfully, and we are inside your election info, right? So if I just go over here in my remix ID, and if I just click on election name again, and yes, class monitor, you can see. Perfect. That means our smart contract is interacting with our Flutter frontend, right? Now over here, what we need to do? So over here, we need to first of all create a row, and inside that we will have two text, total number of candidates, total number of votes, right? So let's do that. So election info, and in the app bar, first of all, we will have a scaffold. Yeah, that is done. In the app bar, we will have a body, and the body will have container. The container will have padding, edge insets dot all, let's keep it 14, and child, column, children, and in the children we will have first of all a sized box of height 20. Let's give it a row now. Row will be children, and in the children we are going to have again a column. So let's skip column, children, and in the children I'm going to have a simple text. The text will be, let's keep it 0 for now, and the styling will be text style, and let's keep the text style as font size. Let me just keep it 50, and let me make the font weight as bold. Font weight bold. Let me just save it. I'm having 0 over here. So after this text, I'm having another text, and the text will be total candidates. Let me just save it. Total candidates. But now what we need to do is, and the row will have main axis alignment. Main axis alignment dot, let's keep it space evenly. Perfect. But you can see that this text is not real number of candidates, right? So what I want to do is I want to call this function, get number of candidates, and that value I want to put it over here, not a static 0, right? So for that thing, we need to wrap our this text into a future builder. So let's do that. So I'm having this column, yes, and this text will be wrapped inside. So let me just wrap it with a stream builder, and let's make it future builder. And I'm also going to give you one task, very simple task at the end of this video, so that you need to do, and it will be future, and the future will be nothing but my get candidates number, this one. So this function we have already coded in our functions. So this we are going to get, and it is going to return me a list. So let's do that. And Ethereum client will be nothing but widget.ethereum client, that we are taking it from home.dot. And till the point it is loading, so what we will do is in the builder, if snapshot dot connection state is equal to connection state dot waiting, I'm going to return center child circular progress indicator. Perfect. And if it is loaded, instead of simple 0, I'm going to write snapshot dot data dot to string. Loading, and it is 0. Perfect. So that means there is no error. That means it is the value from the backend, and it is showing like this. What I'll do is, instead of dot data dot string, I will make it at 0. That means index 0. Perfect. This is it. Now in the same way, we will write total number of votes, and we are having this total votes over here. But have we coded that function? So let me just see. No, we haven't coded that function. So let's do that first. So instead of, like, let's copy this get candidates function. Let me just copy it. Let's paste it. Let's change the name as get total votes, and it will be total votes. Okay, that is not there over here only. So we haven't coded in the smart contract. That's totally fine. So okay, we need to return this only, total number of votes. Okay. Over here now I have written this function, but I'm not going to save it, because if I'm going to save it, then my contract address, then we have to again deploy it, and then we have also need to write this function. So let's just comment it out. Now it is your task. You just need to copy this function, paste it, change the function name, and instead of that, just call this function, and it is going to return you total number of votes. So it is returning in the uint because our total votes over here is in the uint format. So this is your task. This is a very simple task, right? I know you can do it. And yeah, let's move forward. So first, what I'll do is in election info, I'm going to copy it, total number of candidates, and let me just copy the whole column, and let me just paste it over here, and it will be total votes, right? And I'm not let me just remove the future builder, and let me just make it static only, because you will do it by your own, right? So it is not there. Okay, let me just make it return text itself, and let's remove all these things, and it will become simple 0. This will be gone, and I think one more bracket. Yes, let's save it. Total votes. So this is static because this is your task to call this function instead of calling get number of candidates, right? So I think you can do it. Now let's move forward. Now what I want to do is I want to have two text fields. So first text field will be to add a candidate, and second text field will be to authorize a voter, right? So let's do that. So at the end of this row, I'm going to write a sized box to have some spacing, and let's give it height 20. And now I'm going to have a row again, and this row will have children. Children will be text field, and this text field will be, so let's define two text editing controllers. Let's define add candidate controller. Let's initialize with text editing controller, and another one will be text editing controller, and this will be authorize voter controller is equal to text editing controller. Perfect. Now let's go over here, and the text field, this one will be for add candidate controller. It will be having a decoration, input decoration with the hint text, and the hint text will be enter candidate name. Perfect. Let me just remove it. Yes, and in this text field, let's make it expanded, wrap with a widget, and after this text field, or after this expanded, let's have a elevated button, and this will be having a child text add candidate. This is going to call this call the function of add candidate. Yes, name will be controller, that is add candidate controller dot text. I hope you are understanding everything. And ETH client will be widget dot ETH client. Perfect. This is it. So let me just save it. What is the error? So there was no error. I just needed to refresh the app. So this is it, and we can see add candidate over here. So now what my task is to write the candidate name. So let's say one candidate is Akshit, and let me just click on add candidate, and let's wait what happens. Yes, candidate added successfully. That means this function has run successfully, add candidate. And now let's click on let's search for zero index, click on candidates, and it will show me okay, there is an error, election.candidates VM execution error. So if I'm clicking this get number candidates, I'm getting 1, but I'm not able to get the candidates info. So no problem, let me just refresh it. So it should show 1 now. Yes, 1 total candidates. And if I just add one more candidate over here, let me name it Asif, and click on add candidates. Let's see. Yes, candidate added successfully. Let me just refresh. Okay, let's save again. Yes, two total candidates. So this is also working. So thing that is not working is this candidates information. So let me just do it once more. Yes, now I'm getting the election, the candidates information. Maybe last time it was still processing. Let me write one index and it should show Asif. Perfect. So this is working perfectly. Now we need to write, let's copy this row, and we need to copy this row and paste it one more time. And this time it will be for authorize voter address. Enter voter address. Perfect. And we need to call, the function will say add voter or authorize voter or add voter, and function will be running authorize voter function. Address will be authorize voter controller dot text. Ethereum client will be widget dot eth client. Perfect. Easy. Now what we need to do? So to authorize a voter, we need its public key. This you know. Let's go over here. We know that our public key is this one, account 2. So let's go to account 2, copy this public key. Let's paste it over here. Paste and click on add voter. There should not be any error. Yes, voter authorized successfully. And now we can use this address, or we can use account 2 to make a vote. So this is clear, right? Okay, so our major task is done. Now we need to show a list view dot builder, and inside that list view dot builder we will be having all the candidates information, and aside of that candidate's name we will have a button to vote him or her. Perfect. So let's do that. So what I need to do is, I will be defining, after this row I'll be defining a divider and a future builder. So this future builder is going to get a list, right? So it is going to get a list, and it will be having a future of get candidates number, right? And widget dot eth client, and it will be having a builder, and builder will be having context and snapshot for sure. Context comma snapshot. And let's copy that thing. Like if it is loading, then we need to show loading widget or circular progress indicator. Perfect. And if it has already loaded, then what we need to do? So if it is loaded, then we need to return a column. Column will be having children. So instead of using list view, I prefer using column with for loop, right? So let's write for int I equal to 0, and it is going to run till the length of the list that we have got. So it will be I less than snapshot dot data, and we will again have that thing like the result which we are going to get, it is in the form of list, right? So we need to access data at index 0. That means the number that we are searching for, the total number of candidates. That means this 2, right? So this 2, and it is going to, we need to convert it into int because it will come in uint. So let's convert it into 2 int, and it will be I plus plus. Yes. Okay. Semicolon. And we need to return again we will be returning a future builder, right? Because now we have just got the number of candidates. We need to go inside that candidate list, access the candidate present at a particular index. The index is nothing but my I, right? So let's return future builder, not return, just return future builder. And this time my future builder will be again having a list. This may sound a little complex, but you are going to get the complete code. You can like revise it any number of times, right? So future will be my candidates info. So there is a function that we have written. So candidates info function. So I think we haven't written it. So let me just see. Yes, candidates information function we haven't written. That means, yeah, we We haven't written the smart contract also. So I think we need to once more deploy the smart contract. So this is the function. So this function, what it takes is it takes the index of the candidate from the list, and it returns you the candidate. Return candidates at that index. So you can access his name, you can access the number of votes he has got. So let's save it. And now we need to do one more thing. We need to redeploy it. So let's delete the deployed contract, and we need to once more, ABI. We need to once more copy the ABI because more functions are added. And now I'll code this function also. Now I'll show you how you can do it. So no homework from my side. So let's go over here, and we should on account 1 because account 1 will deploy. So let's deploy and click on confirm. Gas fees will be charged, and it is pending currently. Let's wait. Yes, my contract is deployed. Now our contract address will change. So let's copy this contract address, and in our constants we need to change our contract address. So let's paste it over here, save it. And now what we need to do is, if we will see our contract, now our election name will be gone because we need to write it again. So I will rerun it, but before that I am going to write one function over here in my functions.dart. So like two functions. First is this get total count, because that I gave you homework, but let's leave it. So it will be get total votes. So let's copy it and let's paste it, get total votes. And now one more function will be there. So let me just write it. So it is future list candidate info. It takes a uint index, and it takes the web3 client, ETH client, and it calls the function list dynamic will be the output type. So list dynamic result is equal to await ask. Function name will be this candidate info. So let's copy this. Let's paste it over here. Arguments will be empty. No, not empty. We need the index. So let's give it big int dot from, and let's take it in the int format only. And the value will be index. And yes, so I think this is it. And Ethereum client we will pass, and now we need to just return the result. So what it is going to do is, it is going to return you all the candidates information. Sorry, not all the candidates. It is going to return you the candidates information present at this index. So this is it. Now in the election info, we need to run this function only, the candidate info function. So future list future builder, and my future will be candidate information. Index will be my I, and Ethereum client will be widget.eth client. Perfect. And now what I need to do is, I need to define a builder, and the same thing. If my builder is loading, so if it is connection state dot loading builder. Okay, let's copy it from here and let's paste it over here. And if it is already loaded, then else. So let's solve this. So here we need a semicolon, and here we need this. Perfect. So and again, this will not be snapshot, because snapshot we have already defined here. So let's make it candidate snapshot. So let me just name it candidate snapshot. Let's click Control C, Control V, and yeah, now I will be returning a list tile, and this list tile will have a title, text, and the text will be name, of the candidate. So name will be plus candidate snapshot dot data at so let's just print the candidate snapshot dot data dot to string first. Let's see what we get. And for the subtitle also, let me just copy this complete text. I basically want to show the number of votes. So over here name, I'll say votes, and let's print this only for now. And in the trailing, I'll be having an elevated button. On press will be like this, and child will be text. So the voter can vote from here basically using this function. And we need to call vote function on from this button. Candidate index will be my simple I, and ETH client will be widget.ETH client. And we are done with the coding part of this application. Congratulations. Now let's refresh the app, and we need to put the election name as class monitor. And we can do one more thing now. Instead of like the homework which I gave you, let me just wrap it with the future builder. So let's just copy this future builder and paste it for this column, for this text basically. Yeah. So yes, I think this is correct. Yes, so this is correct. And instead of calling get candidates number, I'm going to call get total votes. What is the function name? Yeah, get total votes, and widget.eth client, and everything will be same. Snapshot data at 0 to string, and I'll copy this also, and I'll paste it over here. Total votes. Let's save it. Let's refresh the app. Now just focus on this screen. Let's name it class monitor election. Click on start election. It should start the election. Everything will be 0 for now. Candidate name, let's put it Akshit. Click on add candidate. Candidate will be added. Candidate added successfully. For now I have not wrapped with stream builders. That's why I'm not getting instant. I need to like click on hot restart. That's why I'm seeing this result. But you can see total candidates is 1, and you can see over here. So this is not looking good. So that's why what I'll do is this Akshit is the name, and this 0 is my total number of votes. So what I'll do is in this future builder snapshot.data at 0. So this is complete parent list. Inside that I am having a list. So at 0, that means my first index. So I'm having only one data only. At 0, 0 means my name. So let's copy this. Let's paste over here. Now this 0 will become 1 because 1 in the index, at index 1 only we are having total number of votes. So let's just save it. And we should see Akshit and 0. So let's add one more candidate, and let's call it Karan. Let's click on add candidate. Candidate will be added. Yes, it is added. So let's just Control S, and we should see total candidates 2. So basically what you can do is to remove this always like hot restarting, you can define a refresh button. That's it. And we can see 2 candidates. Now let's add one more candidate, and let's click on, let's say Asif, and it will be added. Let's wait. Yes, candidate added successfully. Let's Control S. 3 candidates, and yes, now I'll authorize a voter. So for that I'll require the public key of that voter. So account 2, copy the public key, paste it over here, and click on add voter. So voter will be authorized. So voter authorized successfully. And now what I need to do is when I'm going to click on vote, I'll be creating a transaction with the voter's private key. So as you can see over here, so in the functions, if I'm voting, now I have given voter private key. Now gas fees will be cut from voter's account, right? So let's click on vote. So let's see what we get. we should, yeah, vote counted successfully. So let's just save, and total vote should be 1. So you can see Akshit is having 1 number of vote, and now I cannot vote again. So if I try to vote again, I'll see like some error over here, right? Some error I'll see. So this error we should also show in the front end, but I think that you can do. So if I just save it and I try to vote Karan, I should see an error. You can see because I've already voted it, right? So yeah, this is it. So let me just push it on the GitHub so that you can see, and let me make a commit called final, and let's just make the commit. So I hope you like this video. It was a long video, but that's totally fine. I think you can make any kind of project from here, and you can also put it in your resume. This is a Dapp decentralized application, and I hope you liked my work. You can support me on Buy Me a Coffee, and you can also support me by giving me some Ethereums, so if you want. So I hope you like this, and if you want me to create more projects like this in front of you, you can write interested in the comment section. And if you want me to teach you blockchain in Hindi or English, you can also write interested in the comment section, and write the language also in which you want to study blockchain, because I'm thinking of a plan. So I hope you like this series. Till the next content, keep coding, keep innovating, and thanks a lot.